Hey everybody, you should have chapter 10 notes, the limits and the derivative, section 4. We're going to start with the derivative, but again, just kind of do it like we would in class. Have the notes, take the notes. I think that's most effective. But other than that, I'm going to go ahead and get started with the first part. We're introducing, we're talking about this average rate of change, and before we kind of knew average rate of change was a slope when you talk about algebra, but I'm just going to draw some, random function, kind of similar to what's on your page, okay? But here, let's just say that we wanted to find the slope at that point A. How might we do it? Well, we could get an estimate of between these 2 points, and we can find that slope between those lines. I should probably use a different color, but that's the idea, is we're trying to get a slope of this line to estimate the slope at that point, which this line is called the secant line. Okay, now how could I get a better slope to estimate A? Well, right here, we'll just call this distance a distance of h. So then that means this point right here is A plus h. So how can I get a better estimate of A, or the slope at A, the slope at that point on the curve? I can bring my h, or make that h smaller, and the closer and closer I bring it to A, the better estimate I get. But for now, we're just trying to find this slope, or what we know as the average rate of change. Now before, you kind of knew if you had 2 points, kind of like I have here, and I called them x2, y2, what can you do? You can find the slope with this formula, y2 minus y1 over x2 minus x1. And then the slope, I mentioned this, was also called the average rate of change. So, but if I think about what I have here on this picture, what happens when you substitute A into this? You're going to get f of A. And what happens when you substitute A here? You're going to get f of A plus h. Okay? So with that said, this is like your y2, that's like your y1, that's where you get your f of A plus h, minus your y1 is f of A, over your x2 is going to be A plus h minus A. And then you can kind of see what's going to happen on the bottom. On the bottom, you'll get some cancellation, and the cancellation is going to give us f of A plus h minus f of A over h, which is exactly the average rate of change formula that we had up here. So that kind of shows us that where this comes from. Okay, so that's average rate of change. I kind of mentioned that this picture is going to be important, so here it is again, and then we're going to do another version of that picture in a second. But let's go ahead and kind of use some of the ideas on the next example, and I'm going to go ahead and read it. You have it on your paper. The revenue generated by producing and selling widgets is given by R of x, revenue of x, equals to x times 75 minus 35x. So I'm going to go ahead and write that down. So that's 75, or I'm sorry, x times 75 minus 3x. Okay? And it's asking, what is the change in revenue if production changes from 9 to 12? Okay, so think, what would you do? I want it to go from 9 to 12. Take a second, think about it, pause the video, come back to it. Okay, so hopefully what you should have thought of is you want to plug in 9 and plug in 12, or substitute, right? So then you would do 75 minus 3 times 12, which is 12 times, that's 36, 75 minus 36 is going to be, that's 39. 12 times 39, that'll be 468. That's what I calculate. Okay, but again, you don't need to, I mentioned in class that you don't need necessarily to show all this, but you can kind of skip some steps in between. But R of 9, in fact, I'll show you, at least do the substitution part, and then from there you can just kind of type it into a calculator. Okay, and I get 432. So we have R of 12 is 468, R of 9 is 432. It's asking what is the change in revenue. What do you think we should do? You should subtract R of 12 minus R of 9, which is 460 or 432. I'm sorry, 468 minus 432, which gives you a change of 36. So the revenue went from 9 to 12. It increased by 36. So it might be a good idea for that company to produce at least up to 12 digit or widgets, and that would be a good move as far as making more revenue. Okay, so let's look at the next question. The next question says the same function. What's the average rate of change in revenue per unit change in X if production goes from 9 to 12? Okay, well, how much units did it increase by? Think about that, and then think about what you need to do to find the average. Okay, so you can pause it, kind of think about it, come back to it. Okay, so from 9 to 12, that's 3, right? So if I want the average rate of change, okay, what I really want is how much did it change by over how many increase in units. So that's really going to be 36 over 3, right? Because it increased by 3 units from 9 to 12. So that's it. But let me kind of show it in a longer way to make a point. So you were really doing this, right? And then the change in units was 3. So R of 12, that's 468 minus 432. That's 36 over 3, which is 12. So what did we just find? The average rate of change was $12 per unit increase. So every or per widget, if you want to write that too. So every unit on average will increase the revenue by $12. Okay, according to this. But I wrote it this way because I wanted to show you that it's similar to what we had here. Your A would be 9. And then your H, and I didn't write that here, but it would be 9 plus 3. And then H again on the bottom would be 3. So that's how this mirrors what we have up here. Okay, but that's one application. Okay, let's go ahead and move on to the next sheet. So I'm going to erase this part because I want to do a little comparison. Of course, you have it if you need to go back to it. And my comparison is we're now going to go, this is the average rate of change. We're going to talk about the instantaneous rate of change. Okay. Instantaneous rate of change. Okay, so with this, what we want to do, I know something was bothering me here. Okay, let me just put that correctly. What we want to do is I'm gonna draw kind of a similar picture. In fact, I'm gonna try and just mirror this one. And now here the question was, how can I get an estimate? Now I'm going to ask, how can I get the slope, not an estimate? So the estimate was between 2 points, a secant line. I want the actual, what we call, slope of this tangent line. Now the tangent line only goes through 1 point in that area. Okay, so how do I get that? It's kind of the same idea, right? You still have this, we talked about it earlier, how do I get a better estimate? Well, get a closer point, right? But what's the closest point that I can get? I'm still going to do, this is A, this is f of A, the point above that, that's f of A plus h, right? And that distance is still h. But how do I get the closest point possible? Okay, the closest point possible will have to be with something we've been learning about, which is the limit. So I'm going to take the same exact thing that we did with rate of change. Okay, so the formula looks the same, other than now I'm going to throw a limit in there, because how do I get the best estimate of that slope of that tangent line? Is I have to get the limit as h goes to 0 if I want exactly at that point A. So as h goes to 0. And that's the formula for what we call the slope, or we call the instantaneous rate of change, also called IROC. And then this is also called the slope of the tangent line. And then if I wanted to add some stuff here, this would be AROC, and we could also call this the slope, I'm going to kind of squeeze it in here, slope of the secant line. Okay, so those are some distinctions to make. But that's kind of the whole idea. Again, I told you I'll probably be drawing that more, so it's probably pretty important, so you can kind of save this video, come back to that explanation. But let's go on to the next part, which we have, this is also called actually the derivative. Okay. Derivative. Okay. And so that's another definition. So all these terms are important because you could be asked a question in any format of this, and it's basically the same process. So as long as you know the verbiage, you're going to know what to do. And then we talk about things that are differentiable on certain intervals, and we'll talk more about that. But basically, what it helps us do is it finds the derivative helps us find slopes on a curve at different points on the curve. Okay. So we're going to jump down to, oh, actually one more thing. So you have one thing that's mentioned here. If you throw a ball, right, and you have what we call, this might be time, and this is your position, or maybe the height of the ball. So this is a position function, okay, or I should really call it PFT because I have in reference to time. If you take the derivative of the position, you're going to get velocity. Okay, and then if you take the derivative of velocity, guess what you're going to get? You're going to get acceleration. Okay, so those are some relationships. The rate of change of position is called the velocity, and the rate of change of velocity is called the acceleration. So those are some relationships that we'll see. But let's go ahead and go to the meat of this, which is the 4-step process you'll see. And we're just going to do that with an example. Okay, which is the following. So now I'm going to erase this side at least. And we're going to do that 4-step process. It's listed there on your paper, but I'll kind of write it out for this one for you. So the first thing on the 4-step process would be that you want to take f of x plus h. So step 1. Well, first let me write f of x. F of x equals x squared minus 3x. Okay, step 1 is f of x plus h. Okay, so we're going to do that. So what does f of x plus h mean? That simply means you're going to substitute x plus h into the equation. And from here, you'll just do a little algebra. X times x, x squared, x times h, xh, h times x, xh. So that's 2xh minus 3 times x. If I distribute, 3 times h is negative 3h. And no like terms, so step 1 is done. Okay, so we've calculated step 1. Now on to step 2, which is to do f of x plus h minus f of x. Okay, so f of x plus h minus f of x. Okay, so we already did this part, so we're just going to copy that, which is x squared plus 2xh minus 3x minus 3h minus f of x. Now, you want to be careful here. Don't put minus x squared without, you want to put it all in parentheses because you're subtracting all of f of x, which is x squared minus 3x. So you got to subtract it all. You got to make sure you put in parentheses because otherwise you're just subtracting x squared. But really what you should be doing, what you'll see on the next step, is distributing this, which we're going to get x squared plus 2xh minus 3x minus 3h minus x squared, because the negative x squared, and the negative negative, that turns to plus 3x. So this is what you end up with. And then step 2, well actually, do you see any cancellations? What cancels here? You'll have the 3x, the negative 3x, and the 3x. Then you'll also have the x squared and the x squared. So at this step, you should see a lot of cancellation. If you don't, there might be something wrong there. You might want to check your work. But what you're left with is 2xh minus 3h. So that's step 2. Now step 2 is done. Okay. All right. So now step 3 is going to be to take it over h. Okay. So basically, the steps are just to kind of help you guide you through the formula that was just shown up here. This formula. We're trying to guide. We're just trying to guide you through this formula. So this is already calculated, right? We already have that f of x plus h minus f of x. That's the top, the numerator. So 2x h minus 3h over h. So from there, if you notice, I can factor out an h on the top. I'm left with 2x minus 3 over h. And then what happens to the h's? They cancel out. So then that leaves me with my answer, 2x minus 3. 2x minus 3. Now, step 4 is to take the limit, is the final step, which is take the limit of as h approaches 0. Now, on a lot of problems, this will factor in. Let me just write the whole step. This is how the steps are written in black. Okay, a lot of times the h or the limit part will factor in, but on this particular problem, all I have is 2x minus 3, right? So that means that I'm taking the limit as h approaches 0 of 2x minus 3, but there's no h. So my answer is 2x minus 3. And again, like with most limits, the first thing you should do is try direct substitution. Okay, so with that said, the next part, the next example, is actually kind of a continuation of this one. All right, so let's look at that. We have, it says find the slope of the tangent line f of x equals x squared minus 3x. Okay, so we already found what we said was, oh, it says find it at those zeros, or those x coordinates. We found the equation. In fact, let me write this. We found the equation of the slope of the tangent line. Okay, doing this process, doing this 4-step process, we found the slope of the tangent line. But again, let me kind of reiterate some things, because it's on your paper, but let me just say it. That means the slope of y, right, if you can see that. Okay, that's y prime is the same thing as f prime of x, which is also the same thing as dy dx. These all indicate that that's the derivative of y. In other words, that indicates that that's the slope of the tangent line, or you have an equation of the slope of the tangent line. So I'm going to start with that. We found an equation, and I'm going to use f prime notation. We found the equation for the slope of the tangent line. With the previous problem was 2x minus 3. This question is not going to be too difficult because we already found this. So since we found the equation for the slope of a tangent line, how do you think we're going to find the slopes at 0, the slopes at 2, and the slopes at 3? Well, that's right, you're going to plug it in. So f prime of 0, 2 times 0 minus 3, which is negative 3. F prime of 2, 2 times 2 minus 3, that's 1. F prime of 3, which is 2 times 3 minus 3, which is 3. And I have my 3 slopes, okay, on this graph. Now, I'm gonna take it a step further, and I'm gonna do this by hand, and I'm gonna show you on the calculator how you can do some of this graphs on the calculator. I'm gonna graph the original function f of x. Okay, so f of x equals x squared minus 3x. So if I plug in some points, well, I could factor too. So if I factor, I get x minus 3. That tells me that I have zeros or x-intercepts on this graph at 0, goes through here, and then 3. I could also plug in points too to make a graph if I wanted to. I just chose to do it this way. Then maybe somewhere in between there, yeah, halfway, maybe like 1.5. What is that? 1.5 minus 3 is negative 1.5 times 1.5, that's 2.25. So it's 2.25, about right there. Okay, but again, that part I mean, you could just plug it into a calculator. You could just type in different points and get the same shape. Okay, so that's not the point of this. The point of this is I want to illustrate what these things mean. Okay, so f prime of 0, they say, has a slope of negative 3. Okay, well, how does that make sense? Well, here's 0. If I were to guess a slope, it would probably be somewhere in that direction. Okay, and and keep in mind this is a sketch, but that looks to be about down 3 over 1, right? A down 3 over 1 slope. So that's why that makes sense. At 0, at x equals 0. At x equals 2, okay, so where's 2? 2's right here. The slope here appears to be positive, okay, which is justified by what we have. And in fact, it looks to be about an up 1 over 1 slope, just like this says. So that's how that makes sense with the graph. And then at 3, our slope again appears to be positive. But if I were to draw a slope there, it would be a little bit steeper. And that appears to be about an up 3 over 1, just like this says. Okay? So that's a rough kind of connection, but that I think that's an important connection for you to make. Now, on the following 2 examples, they have you do it on, or they're looking at it through the calculator. Okay, so on the calculator, I'm going to go ahead and I typed it in there, or I'm going to type it in there. So x squared minus 3x. Okay. And let's do this. So here it is. I typed it in, right? Can you see that? And then from there, we can go to second, push this button, second, calculate, because the second activates the blue buttons, which is also the trace button. And then go to number 6, where it says dy dx. Okay. Push enter. It just draws the graph I already had. Then you'll notice it has that. It has the graph. Now it's waiting for us to type something in. So we can check our slopes. So I'm going to check it. It tells us to check it at 2. So I'm going to check it at 2. So we already found it. Keep that in mind. 2, enter. And you'll notice right here on the very bottom, it tells you dy dx equals 1, which if you kind of look at the board, that's what we said earlier. Dy dx equals 1, or in other words, the slope at that point is 1. So you can kind of play around with that. But here's one more thing you can do. You could also use the tangent function. So you have to go to draw, which is also, you're going to have to push second. And then draw is right below the stat button, or it's the program button. Okay. And then if you see the options, there's number 5, the tangent. You could also push number 5. Okay. And I can ask it for the tangent line at 2. Okay, so at 2, enter. Which we didn't do actually, and you'll notice that says 1x minus 4. So we're going to get that by hand though. Okay, so let me show you that for that type of question. So find the derivative of, yeah, so we did that, but let me continue with this. So, and this is kind of a bonus question, but one that you could be asked. Okay, so we need to kind of cover it. And the question is, find the equation of the tangent line through x equals 2. Okay, on the same graph, on the same function, right, which we're working with, which is f of x for f of x equals x squared minus 3x, right? X equals x squared minus 6. Okay, so first things first, I need an equation of a line. Anytime you need an equation of a line, that kind of lends itself to the point slope formula. So I'm actually going to go back to using this. Okay, and then the other thing I need is a slope. Okay, well actually, at x equals 2, we have the slope. The slope is 1. So that's a plus. We already have that. And then you'll see we don't really need much more. So m equals 1. I have an x1, right? That could be my x1, the number 2, but I need a y1. How am I going to get a y1 from this x1? Well, I can just plug it into the original function. So if I do f of 2, 2 squared is 4, minus 3 times 2 is 6, it's negative 2. So this is what we'll consider, x1 is considered 2, and then y1 will be considered negative 2. Okay, so we have everything we need. We have our slope, we have our x1, we have our y1, we're just going to plug it in. So y minus negative 2 equals to 1 times x minus 2. Solve this, that turns to plus. 1 times x is x, 1 times negative 2 is negative 2. Subtract 2 from both sides, and then y equals x minus 4, just like our calculator said earlier. Okay, so that's how you got to do it by hand. Now again, the calculator is a tool for us. It's more of like a checking tool. You may have it and use it on certain problems, but you are expected to understand, the math behind all this and be able to write out steps with the math. So use the calculator to help you verify things, understand things, and that's how I tend to think of it. And you will even be allowed to use some of it on a test, but keep in mind on other portion of the test you will be asked everything or all the steps. Okay. All right. So just to make sure we got that clear. So the next thing you have, using a graphing calc, find the derivative of f of x equals 2x minus 3x squared using a graphing calculator with the symbolic differentiation routine. So I'll just show you that real quick. You can type in, so if I go out of this, let's see, can you see that? I know this is a little rough here. I don't know, seems like at an angle it works a little better. Okay, so we're going to clear this out, or just get out of there and go to the home screen. Okay, and if I push math, which is along the left side underneath the alpha, I can go to the 8th button, which is nderive, and then I can just push that, and now I can literally type out my derivative. Okay, and then before I do that, okay, so you got there. Okay, let's write it on paper what we're trying to find, which on paper, the example that I'm working on is f of x equals x, or 2x minus 3x squared. And what we want to do is take the derivative of this function. Okay, so another notation we can do is take the derivative of f of x in as respect to x. So we could also say the derivative of all this. Okay, that's what we're trying to do. So that's another notation, okay, not mentioned earlier, but that's the notation we're going to use in our calculator with the added step that we're going to put on the calculator. We're going to write x equals x. Okay, and I'll show you what I mean. Okay, so basically I'm going to go back to here. I'm going to type in x. I'm going to go to the parentheses, and then I'm just going to type in my equation, 2x minus 3x squared minus 3x squared. Okay, now that I did that, I'm going to go to the right, and I'm just push x equals x. Then I'm going to push enter. Oh, you know what? Give me a second. Okay, so after a little bit of research, I found that we couldn't do find the derivative. And I'll finish showing you. Maybe with this example, it's another way to find derivatives at a point. Okay, so it's useful what we're trying to show here for that, but you're not actually going to get the derivative of the equation. In other words, the results of the four-step process, unfortunately, using these calculators, that's more with the TI Inspire, is what I found out. But here, let me show you this again. At least this is somewhat useful. We can do number 8 in derive. Okay, and then we're always going to put an x here at the bottom. Then I'm going to type in the equation on that problem. The equation was, let's see, it was x squared minus 3x. So I'm going to type in x squared. This is from the previous problem, minus 3x. I'll get to the current problem in a second. And we can evaluate it at, let's just say at 3, right? If we evaluate it at 3, we should get 3, like we got here, okay? So that's just another way to evaluate at a point, or in other words, find the derivative or find the slope of an equation at a particular point. But again, you're expected to kind of know all the work, the four-step process and so forth. And then in the next section, I'm going to give you the shortcuts of the four-step process, so the work won't be as painful, right? But we'll go from there. So with that said, since we weren't able to do that problem with the calculator, we're going to go ahead and do that using the four-step process, which is the next example anyways. So we'll do that. Now, on this one, the steps are the same, right? Step 1, you're going to do f of x plus h. And what that means is you're just going to substitute x plus h into the formula. So 2 times x plus h minus 3 times x plus h squared. 2 times x plus 2 times h minus 3 is going to hang out here while I figure out what's going on in here. X times x, x squared, x times h, xh, h times x, xh, that adds up to 2xh. H times h squared. Okay. I'm going to have to distribute the 3. So a bunch of algebra. I told you you're going to have to brush up. Negative 3 times 2 is negative 6. Xh, negative 3 times h is negative 3h squared. And then I'll see if there's any cancellations, which there usually is. But if not, that's okay. So I don't see any. So we're going to kind of keep going. Okay, so this is what I have so far. And